Welcome to Pulsar's Career Point. This is a video for the student of class 11 on practice series for chapter review test CRT for class 11 as per CTC Council of Higher Secondary Education Odisha. Most probable questions on the chapter chemical bonding. This is the part 1 video for this chapter. This video contains different probable questions from chemical bonding. The total mark for this test is 20 marks and the total time duration is 45 minutes. The time distribution. Question paper reading and understanding 5 minutes. Question number 1 carrying 6 marks and which is to be covered within 12 minutes. Question number 2 6 marks is to be covered in 12 minutes. Question number 3 8 marks and is to be covered in 16 minutes. Now let us come for the welcome to all of you to the objective section where all the questions are compulsory. According to the current system, it contains only multiple choice questions, but here the questions are of short types. Total mark is 6 and total time allotted is 12 minutes. Out of the following, which hybridization is carried out in xenon difluoride? Option A, sp3, option B, sp3d, option C, sp3d2, and option D, sp3d3. Which will be the correct answer? Out of the following, which hybridization is carried out in xenon difluoride? Xenon, its outermost electron is 8, 2 fluorine. Total outermost electron in 2 fluorine atom is 14. So 14 plus 8, there is 22 numbers of electrons are there. Whenever 22 is divided by 8, then 8 2 is 16. Remaining is 6. 6 means 2 3 is 6. 2 plus 3 5. So sp3d hybridization. If the question is asked for hybridization carried out in xenon difluoride, it is sp3d. If it is for xenon tetrafluoride, then it is sp3d2. If the question is asked to identify the hybridization in xenon hexafluoride, the answer will be sp3d3. So after calculating the total number of valency electron, we can predict the type of hybridization carried out in the compound. Thus the correct answer is sp3d, that is option B is the correct answer. Let's come for the question number 2. How many sigma and pi bonds are there in ethylene? Ethylene is otherwise IUPAC, it is known as ethene. CH2 double bond CH2. So total number of sigma bonds is 5 and total number of pi bond is 1. One double bond is there which contains 1 sigma 1 pi and 4 sigmas are there with 4 hydrogen atoms. Now let us come for question number 3. What is the shape of ammonia molecule? Option A, so ammonia belongs to Ab3L type, thus it is pyramidal geometry. How it is Ab3L type? We would go for the total number of valency electron in the nitrogen atom. There are 5 electrons. Out of these 5 electrons, 3 are take part in bonding with 3 hydrogen atoms and 1 lone pair of electron is there. As it belongs to Ab3L type, it is an irregular geometry which is the pyramidal geometry. What is the unit of dipole moment? The unit of dipole moment is dBA. 1 dBA is equal to 10 to the power 18. Now come for question number 5. Why HF is a liquid whether HCl is a gas? Due to the intermolecular hydrogen bonding, HF is a liquid. HCl is a gas due to absence of intermolecular hydrogen bonding. Whether N2 is diamagnetic or paramagnetic in nature. How can you identify the magnetic nature of a substance? Here, in case of N2, there is no unpaired electrons. Due to absence of unpaired of electrons in the MO diagram, nitrogen is diamagnetic in nature. Now, welcome to all of you to the subjective section where 3 questions are to be answered out of 4. In each question require more than 4 minutes to write the answer. The total mark is 6 and total time allotted is 12 minutes. First come to the what is hydrogen bond? Describe its kinds. What do you mean by hydrogen bonding? A weak electrostatic force of attraction between covalently bonded hydrogen atom of one molecule and electronegative atom like nitrogen, oxygen, fluorine of another molecule of same or different type substance is called hydrogen bond. It is denoted by a dotted line. Types of hydrogen bonding. Hydrogen bonding is of two types: intramolecular hydrogen bonding and intermolecular hydrogen bonding. First come to intramolecular hydrogen bonding. If the hydrogen bonding takes place within the same molecule, then it is called intramolecular hydrogen bonding. For example, in case of orthohydroxybenzaldehyde, the hydrogen bonding carried out between the oxygen of carbonyl carbon and H of OH is an example of intramolecular hydrogen bonding. In case of orthofluorophenol, it can also be carried out likely. Now come for the type number 2, intermolecular hydrogen bonding. If the hydrogen bonding takes place between different molecules, then it is called intermolecular hydrogen bonding. It can be carried out in between HF, water and ammonia also. Now, let's come for the second question. What is sp3d2 hybridization? Explain with an example. sp3d2 hybridization. The intermixing of 1s, 3p and 2d atomic orbitals of an atom to give a new set of equivalent orbitals is called sp3d2 hybridization. Formation of sulfur hexafluoride molecule. It involves the following steps. The electronic configuration of sulfur is 1s2, 2s2, 2p6, 3s2, 3px2, 3py1 and 3pz1 in ground state. In excited state, one of the electron from 3s is excited to vacant 3dxy. First from 3px to 3dxy, then from 3s to 3dyz1. Thus, there are 5 half-filled orbitals in case of sulfur. In case of fluorine, the electronic configuration is 1s2, 2s2, 2px2, 2py2 and 2pz1. Here, sp3d2 hybridization is carried out. All the 6 sp3d2 hybrid orbitals contain half-filled electrons which can form bonds with 6 fluorine atoms. The 6 half-filled 2pz orbitals of 6 fluorine atoms undergo head-on overlapping with 6 half-filled hybrid orbitals of sulfur atoms to form 6 sulfur-fluorine single bonds. The structure of sulfur hexafluoride is likely this. Another example can also be taken: formation of xenon tetrafluoride molecule. First we have to draw the electronic configuration of fluorine and xenon. After that, we have to go for the hybridization. Means xenon in the ground state contains 5s2 and 5p6 in the outermost state electronic configuration. So one of the electron from 5pz is excited and 5py is excited to vacant 5d orbitals. As a result, we will get 4 half-filled sp3d2 hybrid orbitals and 2 pair. These 4 sp3d2 hybrid orbitals take part in bond formation. The structure of xenon tetrafluoride is square planar with the fluorine xenon fluorine bond angle is 90 degrees as shown below. Let us come for question number 3. Write down the difference between sigma bond and pi bond. What are the differences between sigma bond and pi bond? The covalently bond which is obtained by head-on overlapping of S's, sp or pp atomic orbitals is called sigma bond. The covalent bond which is obtained by sidewise overlapping of pp atomic orbitals is called pi bond. The sigma bond, it is a single bond it is a strong bond due to maximum overlapping of atomic orbitals. But in case of pi bond, it is a weak bond as the extent of overlapping of atomic orbitals is very small here. Now come for another difference. In case of sigma bond, it consists of one electron cloud that is having overlapping, that is here overlapping takes place in one region. But in case of pi bond, it consists 2 electron clouds That is, overlapping takes place in two regions. In case of sigma bond, it is an primary bond or auxiliary bond, but pi bond is a secondary bond. Across a sigma bond, free rotation is possible, but across the pi bond, the free rotation of atom is not possible. These are the difference between the sigma bond and pi bond. Now, describe VC pair theory, valency shell electron pair repulsion theory. This theory is used to predict the shape of molecule. The main postulates of this theory are the unpaired electrons in the valency shell of the central atom form bond pairs with the unpaired electrons of the surrounding atom, but the paired electrons remain as lone pair. The bond pairs and the lone pairs always repel one another. The electron pairs around the central atom remain in such a way that the force of repulsion among them is minimum. The force of repulsion is minimum when the electron pairs are maximum apart from one another. The force of repulsion among the lone pair and the bond pair is not same. The order of repulsion is lone pair repulsion is more than lone pair repulsion is more than bond pair repulsion. Welcome to all of you to the descriptive section. Here 2 questions are to be answered out of 3. Each question requires not more than 8 minutes to write the answer. Total mark is 8 and total time allotted is 16 minutes. Describe the main postulates of MOT, molecular orbital theory. Draw the MO diagram of oxygen molecule. So, compare the different postulates of MOT. All the atomic orbitals of the bonded atoms take part in the formation of the molecule. Not only the valence electron, but all the electrons present in the atom take part in bonding. Atomic orbitals of nearer energy combine to give molecular orbitals. Bonding orbitals help in bond formation and antibonding orbitals opposes the bond formation. Each molecular orbital has maximum 2 electrons with opposite spin. The shape of the molecular orbital depends upon the shape of the combining atomic orbitals. The molecular orbitals are arranged with increasing order of their energies. The pairing of electrons in the degenerated molecular orbitals takes place by Hertz rule. Application: it is used to predict the bond order, stability and magnetic property of the molecule. Bond order: the number of covalent bonds present in the molecule is called bond order. The bond order is equal to half of the difference between the number of bonding electron and number of antibonding electron, that is half into Nb minus Na, where Nb is the number of bonding electron and Na is the number of antibonding electron. Stability: the molecule is stable if Nb is greater than Na, but it is unstable if Nb is less than Na or Nb is equal to Na. Magnetic property: molecules with unpaired of electrons in the molecular orbital electronic configuration are paramagnetic in nature, otherwise it will be diamagnetic. MO diagram of oxygen molecule. First we have to draw the MO diagram. After that we can calculate the number of bonding electron Nb and Na, and from the value of Nb and Na we can calculate its stability, bond order and magnetic property. Question number 2, what is lattice energy? What are the factors on which it depends? Calculate the lattice energy of magnesium bromide. Given that enthalpy of sublimation of magnesium is 148 kJ per mole, enthalpy of evaporation of bromine liquid is 31 kJ per mole, ionization potential of magnesium gas is 2187 kJ per mole, electron affinity of bromine is minus 331 kJ per mole, enthalpy of formation of magnesium bromide is minus 524 kJ per mole, enthalpy of dissociation of bromine is 193 kJ per mole. Now come to know what is lattice energy. The amount of energy released when 1 mole of ionic solid is formed from its constituent gaseous ions is called lattice energy. M plus gaseous ion plus X minus gaseous ion to give us Mx solid. The amount of energy released here is known as the lattice energy. Now, what are the factors on which the lattice energy depend, or factors influencing the lattice energy? First come to the size of ions. Smaller the size of cation, greater will be the lattice energy. That is, a smaller cation polarize the anion more effectively than the bigger size cation. So polarizing power of cation is mainly influenced by the charge of the ion and the size of the cation. The cation in anion polarized to give the ionic bond as shown in the diagram. Similarly, increase in the size of the anion, there will be increase in the value of lattice energy as the species is more polarized towards the cation. Charge on the ion. Greater the magnitude of charge on the ions, both of cation and anions, higher will be the interionic attraction and thus greater will be the value of lattice energy. Polarizing power of aluminum 3 plus ion is more than magnesium 2 plus ion is more than Na plus ion. Similarly, the polarizing power of N3 minus is more than O2 minus is more than F minus. Calculation of lattice energy by using Born-Haber cycle. First we have to draw the Born-Haber cycles. Born-Haber cycle for the formation of ionic solid MgBr2 can be described as follows. First, the magnesium, in the direct process, magnesium solid combines with bromine liquid to give us MgBr2 solid. The energy taking place is enthalpy of formation, but directly it is not possible. By giving enthalpy of sublimation, magnesium is first converted to magnesium gas, and by giving enthalpy of vaporization, bromine liquid is converted to bromine gas. After that, the bromine gas is decomposed, is dissociated to give bromine gaseous atom. By giving total ionization potential, that is first ionization potential and second ionization potential, magnesium become Mg2 plus, and by gaining 2 electrons, 2 bromine becomes 2 Br minus. By eliminating 2 electron affinity amount of energy is a result by losing lattice energy U, they give us MgBr2. In the problem, question it is given delta Hs, delta Hb, total ionization potential, delta Hd, and electron affinity, enthalpy formation also. By using this, we can calculate the lattice energy as follows. Applying the Hess's law of constant conservation of energy for the above process, we get delta Hf is equal to delta Hs plus delta Hb plus delta Hd plus total ionization potential plus twice of electron affinity and lattice energy. Thus, lattice energy is equal to delta Hf minus delta Hs minus delta Hb minus delta Hd minus total ionization potential minus 2 electron affinity. By putting the values given in the problem, it is calculated to be minus 2421 kilojoule per mole. What is hybridization? Describe the different types, conditions, and characteristics. What do you mean by hybridization? The concept of intermixing of atomic orbitals of an atom having nearly the same energy to give exactly equivalent orbitals with same energy, identical shapes, and symmetrical orientation in space is known as hybridization. Now, steps of hybridization. Hybridization involves 2 steps, or hybridization takes place in 2 steps such as promotion or excitation, secondly reorientation. Promotion or excitation. If number of unpaired electrons of an atom is less than its valency, then one or more electrons jump from one subcell to another subcell. This is promotion or excitation. For example, the electron configuration of carbon, in the ground state it has been found that only 2 half-filled orbitals are there, that is 2px1 and 2py1. Here the carbon atom has 2 unpaired electrons, but valency of carbon is 4. So one of the electrons jumps from 2s to 2pz subcell to give 4 unpaired orbitals in this way. This is promotion or excitation. Now reorientation. In this step, required atomic orbitals intermix with one another to give hybrid orbitals. Conditions for hybridization. The atomic orbitals should present in one atom. The energy difference between the atomic orbitals should be less. One of the atomic orbitals should be different from the other. Only the atomic orbitals take part in hybridization, but not the electrons. The hybridizing orbitals must differ only slightly in energy. Characteristics of hybridization. The number of hybriditals is equal to the number of hybridizing orbitals. All the hybriditals are equivalent in shape, size, and energy. A hybridital cannot accommodate more than 2 electrons in it. That is obey Pauli's exclusion principle. Hybrid orbitals follow Hard's rule. Pairing of electrons cannot take place unless each hybrid orbitals contain at least one electron. The hybrid orbitals having one electron can take part in bond formation, but the hybrid orbitals having two electrons cannot take part in bond formation. Due to electronic repulsion, the hybrid orbitals remain at maximum A part. The hybrid orbitals are effective in forming stable bonds than the pure atomic orbitals. The hybrid orbitals give only sigma bonds, pi bonds cannot be formed. Thanks for watching Bhopal Search Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time.